Hi, my name is Marcos Dimitriou, and today I'll be talking about how you can apply the OCP or Open-Close principle to your programming using the Decorator Design Pattern. According to Wikipedia, the principle states that software entities, be it classes, modules, functions, should be open for extension but closed for modification. The first time I read this, I couldn't quite understand how you can change the behavior of a class without modifying it. But after learning about decorators, it became more clear how I could do that. So today, I'll be showing how to implement decorators using C# and Visual Studio. You could use whatever language you want and apply the same principles. So let's get started. So like I said, the decorator pattern is a pattern that lets you add behavior to a class without having to modify it. We can think of it like an onion that has layers. So each layer is a new decorator. So the first thing we need is a class, is a service, anything that has an interface and respects the single responsibility principle. So I have created a pretty simple calculator service. Its interface has just a sum. It sums two values and returns the result. It's pretty simple. But let's say we want to add a logging feature to it. So if we would do this without the decorator, probably we would do something like, in a very simplified way, append all text. We would have some configuration to return this, but this is just an example. So we can add two values and log those values. Log the result, and there you go. We just added logging to our service. But the problem is, this isn't OCP. We had to modify the class to add the logging we need. So how can we do this with a decorator? So I'm gonna leave it this, and I'm going to create the decorators, and we're going to use this name, calculator service decorator. It's gonna be an abstract class that implements our interface. Okay. It will take a dependency, private read only. That is the class interface itself. I like to call it object to be decorated, and we generate a constructor. And every method of the interface will call the object to be decorator. So, and another requirement is that every method has to be abstract. No, not abstract. It has to be virtual. Every single method has to be virtual, so you can override the behavior later on. So we have our decorator, and then we are going to create the logging decorator. Actually, let's just call this logging. And this is going to be a public class that will implement not the interface but the decorator. And we are going to generate the constructor. And now we will override the method sum. Now this isn't doing anything yet. We have to take that method we added here that line of code and use it here. So we're going to our result and return result. So that's our decorator. How can we activate it so it runs? We are going to do this when we create the class to be used. So we are going to new login decorator, and we are gonna pass the instance of the calculator service. I'm gonna run this step by step so you can see how it works. So we will create this. We will call the constructor. Now it's constructed. We can see that it has the object to be decorated, the calculator service, and the login service has it. So when we run this and call this, the first thing that gets called is the login decorator. And what it does is call the base. The base is the decorator, the abstract class that we created. So it will execute the object to be decorated sum, which is the calculator service itself, the first one that is unmodified. So we have the result, and we go back. Now we are at the login decorator, and we run this, and we return the result, and the result is there, and it's also written in the file. And now it finishes. You can see that no class had to be changed. I didn't change anything. I only changed the way the first class, the calculator service, is created. So let's say that we want to add another behavior, and now we want to send an email every time a calculation is done. So we're going to create a new decorator, email sending decorator, and we are going to implement this based on our abstract class, generate the constructor, and override the same way we did before for our result, return result, and let's just copy this, just add a little more information here. Environment, new line. Let's copy this to here, and this needs to be executed after the result is calculated, because we need the result. Let's call it email sent, and now we need to add it to our constructor. So the way we do this is the same way we did before. Add it here, and now let's see how it goes. When we create the service, we can see that email sending is the first one, logging is the second one, and the calculator itself is the last one, the center of the onion. So when we run this, we can see that email sending is called first, but it cannot do anything before it has the result. So it has to call the base sum. If you are implementing something that has to do something before the execution, you just add it here. Okay, so let's run this. It goes to the decorator that calls the next one. That is the logging that also needs the result first. So calls the decorator, then calls the service. The service does the calculation that is needed, returns, and now we can log. So we're going to log here, and then we'll go back to email sending. We'll send the email and the result, and then this is finished. And we can see here in our log that it has logged the contents and has sent the email. Other use cases for using decorators could be if you have a intermittent service and you want to write a try-catch mechanism, or maybe you have a expensive database call and you want to write a cache for it. Also, you probably noticed that constructing the class can become very complicated depending on the number of decorators that your dependencies have. So I suggest that you use an IOC container to make this simpler. Now, implementing a decorator won't be always as straightforward as was in the previous example. So let's take a look at a new one. In this case, we have a file processor service. What it does is it takes a file path, reads all lines, creates a new file, and processes every line, in this case lowering the strings. Let's say we have a new requirement and we need to add a dot at the end of every line. We say, great, let's use a decorator. But in this case, we can't use the decorator on the process because it only takes the source file path, and we can't know where to write. So we can see this process method is not adherent to the single responsibility principle. So what we need to do is we need to take that part that does the processing of the lines and extract that to a new dependency. So let's do that. So we create internal services, create line processor, create interfaces, create the new service interface, create the class that implements that interface, and for that interface we're going to need a method that returns a string, processes a line. So let's implement that in here, and the implementation is going to be what we have on the file processor service. So let's take that, move it here, return, and now this has to be a dependency on the file processor service, and we added it here. Let's just autofill using, generate the constructor to receive the new dependency, and now we process here the line. Now Visual Studio is telling us that we need to change the constructor to give the new dependency. Okay, now we can run this. We don't need to go step by step. Let's just let it run and see the result. Now this is the input file with upper strings, and this is lowercase version processed. Okay, so now we have to create the decorator. Decorators. Create a decorator base class, which is abstract and implements line processor service. Let's implement that interface. Let's receive the object to be decorated, generate the constructor, and use that object in here. Okay, now we create the add dot decorator. Let's keep this name very simple, which implements the decorator. Needs a constructor. The decorator has to be virtual, every method that we want to implement and override. So now we will override the process. Now var result and return result. Now we do the processing required. So result is result and dot. Now we need to add this to the construction of our class. That is right here. So now we are ready to go. Let's go. So when we create the service, we can see the file processor service, and then the dependency of line processor service contains the add dot decorator, which in turn has the line processor service. So let's run this. So when we get to this and we inspect, we see that add dot was called first and then calls base process, which calls object to be decorated process, and then we get to the line processor that does the lowercase, and then we add the dot here, and let's make it run to the end, and now we can see that the decorators worked and everything is there. As a more advanced use case for using decorators, at work we had to implement a DLL to interface with a system that was running on an IBM terminal. That system had many screens and many navigations possible. So you were at one screen and we press a key and you navigate to another one, then another one, and maybe you press a key and go back to the first or second screen. So it was very complicated. The solution we came up with was creating screen readers and screen navigators, and the navigators were decorators for the screen readers, and we built this with a Fluent API and using the builder pattern with an IOC container behind. So this solution was very easy to maintain, very easy to change, because if a screen changes, you just alter one file. If the way to navigate changes, you change one file. So it was very easy. It works great. So that's it for today's video. I hope you liked it, and I hope to see you in the next one. Bye.